You doing math? I got you. All right, so today I'm going to show you how to add and subtract fractions, but the denominators are not the same. And I'll show you why it's different. So let's go ahead and look at the very first one. So the very first one, before I do anything, what I would like to do is I want to draw a model for you, right? So to understand why you have to do so much extra work just so you can add or subtract. And so the very first number, as you can see, the fraction is 3/4. So what I'm going to do is I'm going to draw a circle and I'm going to draw 4 pieces, right? So if I go ahead and draw a circle, I'm going to break that up into 4 pieces. So we're just going to call it 4 huge slices, right? And so out of the 4 huge slices, as you can see, it says 3 out of 4. So what I'm going to do is I'm going to go ahead and shade in 3 parts. So
did you notice the first fraction? The first fraction was 3/4. The denominator is a 4. This reminds me of quarters, because if you take 4 quarters, which is 4/4, that gives you $1. Since we have 3/4, this would be considered 3/4 or 75 cents.
So 3/4 is represented by that fraction. As you can see, somebody has 3/4 slices of pizza left. So if I go to the other example, you'll notice I now need to add it to a half. And so if I draw my circle, again, we're going to assume that these 2 slices are exactly the same. But this one, as you can see, there's only 2 slices. And because there are 2 slices, the slices are much bigger. The size of each slice is obviously different. Since this says 1/2, I'm going to shade in only 1 part.
Did I just create a brain? No way.
So this part is half. As you can see, I shaded half of the pizza. Now, if I were to combine this, you can't say, oh, I have 3/4 and a half of a slice. Well, how much do you have? How much slices do you have in total? First of all, the slices are not the same. The denominators are not the same. When you name that fraction, those are fourths, meaning I cut it into 4 pieces. This one are cut into 2 pieces. And so they're not the same. And so one thing we do is we list the multiples of the denominator. And so we call it the LCM, right? And so the LCM tells me that I need to list the multiples of 4 and 2. And I'm going to do that on the side. So I'm going to go ahead and do the multiples of 4, 8, 12, 16. Then what I'm going to do is I'm going to multiply or do the multiples of 2 right on the side. So I'm going to say 2, 4, 6, 8. And you'll notice the very first number they share in common is 4. What does that mean?
So I found out that my LCM is 4, which tells me that each pizza I can cut into 4 slices. The first one is already cut into 4 slices, and so I just have to cut the second fraction into 4 slices.
So rewrite that. So 3/4 is just going to be rewritten as 3/4. And if you ask yourself, how do I go from 3/4 to 3/4? Well, remember, whatever you do to the top, you do to the bottom. So I technically multiplied it by 1. And when I multiply by 1, did my value change? No, it stayed exactly the same. So that's what I did with the first one. I didn't change it, but I can still show you what I did. Now for the second one, let me go ahead and go to the model. Now if you look at the model, well, if you have 2 slices, can I just cut that in half? Yes, I can. And as soon as I cut it in half, you'll notice I no longer have 2 slices. I now have 4 slices. So my denominator became a 4. So again, my denominator became a 4. And I no longer have 1 piece. Now I now have 2 pieces, right? So 2 out of 4. And if you ask yourself, how did I come up with this? Well, even if you didn't draw the diagram, you'll notice right here, when we actually did the multiples, the very first number they share in common is 4. And what do you notice the denominators are? The denominators are 4. Why am I allowed to do this? Because the pieces, the size of each slice are the same. Because the size of each slice are the same, I can now add how many slices there are. And so with that being said, again, since I am adding I'm gonna go ahead and add. But before I move on, think about this. How did this half turn into 2/4? Well, ask yourself, how does a 2 turn into a 4? 2, 4, meaning I multiplied it by 2. And so whatever you do to the bottom, I do to the top. So I'm gonna multiply this by 2. And so 2 times 2 gives me 4. And for my numerator, not 1 times 2 is 2. And now what I did was I rewrote, better yet, I created equivalent fractions for each one. Again, 3/4 is 3/4. Well, that's the same. But half is the same as 2/4, right? And because they're the same, I can now go ahead and continue with my math. And in this particular case, as you can see, now the denominators are not unlike anymore. They're like. So that's the strategy. How do you add and subtract fractions when the denominators are unlike? You have to make sure the denominators are the same. And so that requires you to multiply both the top and bottom by the same number. And now we just go ahead and add. The denominator stays the same. You could just write 4, or what you could say is 3/4 plus 2/4 is equal to 5/4. And you can be like, wait a minute, that doesn't make sense. Well, think about it. If I were to take this slice and put it over here, isn't that one whole pizza? That doesn't show one whole pizza. It basically means I would have one whole pizza and then one extra piece left over, right? Again, if I were to take that, put it right here, that would complete my one whole pizza. This is extra, right? This piece right here would be an extra piece. So how does that look when you look at this problem right here? Well, remember, this is an improper fraction. It looks like a 4-year-old is holding up a 5-year-old, and that's not right. And so you ask yourself, 4 goes into 5 how many times? So come by 4. 4, 8. Well, that's too much. 4 goes into 5 one whole time. So you put a big 1, right? And so that big 1 is there, but the denominator stays the same. There's stuff left over. 4 times 1 is 4, plus 1 more is 5. And so to represent this fraction, to represent this model, as you can see, one whole pizza. If I take this slice, put it over here, that's one whole pizza. Then I'm gonna have this one extra slice left over. So this would be the final answer on how you're adding unlike fractions. All right, let's go ahead and look at this one. This one, as you can see, we are subtracting. Subtracting works the same way. The denominators are not the same. So we need to make sure the denominators are the same. So what can you do? You can go ahead and list the multiples of the denominator. The first denominator is a 5. So 5, 10, 15, 20, 25. So I'm just listing the multiples. Once I do the multiples of 5, then I'm gonna go ahead and do the multiples of 3. I'm gonna say 3, 6, 9, 12, 15, 18. And as you can see, the very first number they share in common would be 15. And so 15 would be known as your LCM, your least common multiple. Your least common multiple then turns into your LCD, which is your lowest common denominator. So my new denominator is going to be something over 15 minus something over 15. How do I know this? Because my LCM turned into my LCD. Now what I ask myself is, well, how? Let me box this answer real quick so we know this is not separate. Okay. All right, so as you can see, the 5 turned into a 15. How? 5 times what is 15? As you can see, it says 5 times 3, right? So I'm gonna go ahead and multiply this by 3. But remember, whatever you do to the bottom, you do to the top. So I'm gonna multiply this by 3 as well. And so 5 times 3 is the denominator. You'll notice I already have an answer for the denominator spot. Then I'm gonna go and do 2 times 3, which is 6. So I renamed it. And if you take a calculator, 2 divided by 5, you'll get 0.4. And if you take 6 divided by 15, I guarantee you get 0.4. That's too much confidence. Somebody actually use a calculator and fact check this guy. Why? It's the same fraction. It's just we broke the cake into smaller pieces, right? This cake, there are 5 slices and there are 2 of them. This one, it's that same size cake, but we just cut it into 15 pieces. Why? Because then the pieces are now going to look the same. Same with what? Same with this one right here. Again, this one is 1 out of 3. That means I took a cake and I split it into 3 huge pieces. But if I'm trying to divvy it up, if I'm trying to add them up, you can't do it unless the denominator are the same, unless the pieces are the same. You can't have a big piece and a small piece. It's not fair. You can't do that. And so right here, you ask yourself, how does a 3 turn into a 15? Well, look at your list. 3, 6, 9, 12, 15. 1, 2, 3, 4, 5. So you multiply this by 5. And whatever you do to the bottom, you do to the top. So I'm going to multiply that by 5. 3 times 5 is 15 for my denominator. And for my numerator, 1 times 5 is 5. And now, as you can see, the denominators are the same from previous videos. We know that this is now considered like terms. The denominator is now what gets added. Again, the denominator helps us name the fraction, right? This fraction is 6/15. So 6/15 minus 5/15 is 1/15. I don't have to write that. I can show you on my fingers because, again, the 15th is used to name it. But let's go ahead and do it. As we all know, right, the denominator stays the same. So I'm going to go ahead and keep the denominator as 15. And then all I got to do is take my numerator, which in this case is 6 minus 5. And 6 minus 5 is 1. And anytime you see a 1, you are done. That is already simplified. Versus this one right here, this was an improper fraction. This is fine. Why is this fine? This is a normal fraction. You know what this looks like? This is, when I see this problem, when I see this fraction, I see a 15-year-old is holding up a 1-year-old. That's totally fine. That's like an older sibling. I mean, that's a huge gap. But regardless of the situation, a 15-year-old is holding up a 1-year-old. Maybe a baby cousin or something like that. That's fine. But this right here, that's an improper fraction. And so we are totally finished. I'm going to go ahead and just box my answer. All right, so remember, recap. How do you add and subtract fractions with unlike denominators? You gotta make sure the denominators are the same. How do you know what the denominator is supposed to be? Whatever the denominator is, you have to create a list. Right here, look at this. You have to create a list. And that list, once you create that list, you basically find the LCM, the very first number they share in common. And that very first number they share in common becomes your lowest common denominator. And so once you have the same denominator, you could just add the numbers at the top, which is referring to the numerator.